need to record this too. So first thing we're going to look at is just getting an idea of what a differential is. And we're not really ready to talk about a differential probably till next week, specifically what it is. But dx, that's what's called the differential. And what we're going to look at to prepare us for U substitution, we're going to learn how to correctly write a differential when you do a derivative. So first of all, the idea is whenever you have a function, y equals f of x, when you do the derivative of both sides, the derivative of y is dy, and then you do the derivative of f of x, which is f prime of x, but then you tack on dx. So let me show you why that is. The easiest way to explain this at this point in time is just go ahead and write this down right now. We have dy over dx equals f prime of x. Okay? So what I'm going to do is, you know that's right because those are just two ways to do a derivative. F prime is a derivative, dy over dx is a derivative, right? They're the same thing. So what I'm going to have you do is multiply both sides by dx, and then you will get the result that we're after. And the reason I'm doing that is to get rid of the denominator. So what I end up with is dy, which is a differential in terms of y, is equal to f prime of x times dx. Okay, so what we're going to kind of do, and the purpose of this is to prepare us for the U substitution that I'm going to show you today. Okay, and what we're going to do on this example one's super easy. It's only one little additional thing that you got to learn how to do. Okay, all right, so here's the way I'm going to go about doing this is when we're doing the derivative, we're finding dy. So what you want to do is just write dy over dx. And I know to do dx because the variable has an x in it, okay? Okay, so this is easy. What's the derivative of x to the third? 3x squared, right? Okay, so that's 3x squared, okay? So you're not doing anything new. Now you can even do this in your head if you want to. You just multiply both sides by dx, and then that will give you dy is equal to 3x squared dx. Okay, so, and you can do that in your head. I'll kind of show you in a minute how you can do these problems and just totally in your head without having to write that step. But when you're learning that, I think it's kind of helpful to do that. Okay. All right, next problem, we're going to find du. So you want to write down du over dx this time. Okay, so, and I know it's dx because the function has x's in it. Okay. All right, how do you do the logarithm of 4 minus x squared? How do you do derivatives of logarithms? 1 over the function, then what? Chain rule? Derivative of what's inside. Good. So you do 1 over the function, and then we know the derivative of that function inside is negative 2x. Okay, so we got that. Okay, so that's just a review of what we learned, how to do derivatives of natural logarithms. Now we can multiply both sides by dx, and then we got our answer. Because what you're trying to find is what du is, what that differential is. So you can write this, multiply straight across and get a fraction. So you have negative 2x over 4 minus x squared times dx like that. Okay, so that's the idea of how you can get that done. Okay, so you're just doing derivatives, but there's a way that you write this that maybe is a little different than what you're used to. Okay, part C, okay, you want to find dv. So we're going to do dv over what? See if you've caught on to that. dt, the variable's dt, good, so you do that, okay? All right, now remember when you do a derivative of an exponential, it's itself, but what else do you have to do? Chain rule. Derivative of the exponent. So the derivative of the exponent is negative 6. Okay, like that. Okay. Now what you do is you want to find dv, so you multiply by dt. Okay. And what we'll have is we'll have dv equals, and then you can put this together. That'll be negative 60 e to the negative 6t times dt. Okay, and that would be how you write the answer, like that. Okay, so see, you're doing derivatives, but all you're doing is after you do the derivative, you get that numerator like the dv or the du or the dy by itself. That's it. Okay, and you'll know why I'm teaching you this in a minute. Okay, all right, trying to prepare you for something. Any questions? Okay, all right, you need to get a picture, Danielle. Okay. Okay, all right, so let's go ahead and I'm going to let you all do these three problems. And again, like on the first one, you're just going to start with finding du over dx, which you can do. You do the derivative of that function, and then ultimately you solve that equation for du. Okay, and then see if you can get the rest of them done, and then we'll start going through the U sub. Okay, so on this one, you're going to find du over dx. So the derivative would be 3x to the third minus 2, hold on, minus 4x, I'm sorry, minus 4x plus 1. Okay, then what you're doing is just multiplying both sides by dx, and you can do that in your head if you want to. So you have, what you should have is 3x to the third minus 4x plus 1 times dx. Okay, you really should write that in parentheses too. I don't know if I saw anybody doing that or not, but you want to have the function in parentheses and then that dx just out the side like that. Okay, the next one you start by finding dy over dt. So when we do a derivative of an exponential, it's itself, and then times the derivative of the exponent, which would be 2t minus 2. You really should write that 2t minus 2 in parentheses. So if you didn't do that, you need to do that. Okay. Then what you do is you multiply by dt. Okay, and that gives you what dy is. So you get dy is equal to e to the t squared minus 2t times parentheses 2t minus 2 times dt. Okay, so that's how that gets written. Okay, all right. Okay, nothing to it really. Okay, the last one, you've got du over dy. The reason I'm doing dy is because that's the variable. So we know that the derivative of y to the fourth is 4y to the third. Then you can multiply both sides by dy, so you get the final answer on the problem is du equals 4y to the third times dy. Okay, and the purpose of this for us in this class is to prepare us for U substitution, which is a technique that we're going to learn how to do today on how to do a certain kind of integral. Okay, all right, does anybody have a question about what you did? And, you know, you can do this in your head, guys. I'm totally okay with that. All you do is just do the derivative and tack on dx. Same thing with the next one. You do the derivative and tack on dt. Same thing with the last one. You do the derivative and tack on dy. Those variables are always going to match. So if you have an x, you'll have a dx. If you have a t, you'll have a dt. Okay, so that's how that goes. Okay, so now what we'll do is we're going to do a certain kind of integral that we call U substitution. And if you go down to this, this problem down here, this is an integral that you couldn't do in your head. There's no way to do this in your head. So I'm going to just teach you kind of what you do. What you do is you use u as an intermediate variable. What you try to do is turn this into an easy integral that you can do in your head. So it's kind of analogous to the chain rule where you used an intermediate variable to make that derivative a little bit easier. So the first thing you do is choose u, okay? And I'm going to tell you what to choose, and then I'll tell you why I'm choosing what I'm choosing. So go ahead and write down in that blank for du, that's x squared minus 1. Or I'm sorry, u is equal to x squared minus 1, okay? And what I'm going to do is kind of highlight, use my colors to kind of highlight how I'm substituting in, okay? Now, du, what you're really doing is you're doing du over dx. Okay, so what is the derivative of x squared minus 1 anyway? That's 2x, right? Okay, then you can multiply both sides by dx like I just showed you. So you end up getting du equals 2x times dx. Okay, Now, you don't have to show this step right here. You can learn to do this in your head. It's just you have to have that dx in there to match everything in the integral. Okay, now this is why I did what I did. If I look at 2x dx, I want you to notice that 2x dx shows up in the integral. That's why I did that. You want du to be what's left over in your integral. Okay, so that's why I did what I did. Okay, so now what you do is you make what we call the U integral, so we substitute. So what you're going to do is the part that I have in yellow, that's going to become U. So that's U to the 99th power. And you know how to do that integral. Hopefully you do anyway, okay? And then the 2x dx, that's equal to du. So when you do a substitution, you're basically trying to make sure that everything has been accounted for in the original integral. Does that make any sense to start with? Okay, so du is the derivative of u, but it must match something in the integral. Okay? All right, now tell me what the antiderivative of u to the 99th is. U to the 100 over 100 plus c. Okay? That is the power rule that we learned for antiderivatives. So that's u to the 100 over 100 plus c. Okay, that's an antiderivative. But you have one more step. It's kind of like when we learned the chain rule. I don't want u in the answer. I want the original variable. So what you do now is you take the u and you plug it back in. So what you'll end up getting is parentheses x squared minus 1 to the 100th power over 100 plus c. Okay, so that would be how you would get the antiderivative to that problem. You have to do U substitution. You can't do this problem in your head, like all the other integrals that I've taught you, where you can do them in your head. Okay? Now, I do want to show you on this problem that you can check your answer. So how would I check to tell I'm right anyway? How do I always tell I'm right on an answer to an indefinite integral? Ooh, nobody knows. That's important. You take the derivative of your answer, and what's supposed to happen when you take the derivative of your answer? You're supposed to get what you started with, right? Okay. Now, you don't have to do this on every problem, but it's a worthwhile thing to do, certainly. Like if you're taking, say, a test, and want to know if you're doing it right, then just do it. So you know how to do the derivative of this part. That's a chain rule. So you would have 100 x squared minus 1 to the 99th, and then times the derivative of what's inside, which is 2x. Now this 100 in the denominator is just a constant, so you don't do anything with it. Okay, so you do like a chain rule. Now notice what happens. That crosses out, and then if you look at this, that's back to where you started, isn't it? Okay, so you know you're right. Okay, and that's how you can tell 100% that you're doing these problems right. Okay, any questions so far? Okay, there's kind of like two types of U substitution problems that we'll look at in here. Okay, so again, as I'm teaching this, I'm going to tell you the correct U, and then we'll kind of see if you can start figuring out what that correct U is. Okay, so one thing I see, if I see e to a power in my integral, chances are good that you want this to be e to the u. Because what's the antiderivative of e to the u anyway? E to the u. You want it to end up with an easy integral. So let's let u be ln x. Okay, so we're going to let that exponent be that then. Okay? All right, so what is the derivative of ln x? 1 over x. Now, just be sure you tack on the dx. Okay, that's what I showed you all how to do a few minutes ago. And what I was showing you a few minutes ago is like do du over dx would be 1 over x, then multiply by dx. You don't have to do that. You just need to remember that while you're doing that, you have to tack on that dx. Now, is that what's left over? Yes, okay, that's why that's the correct U, okay? So that's what you have to understand. Okay, now you're ready to substitute. So what does the ln x become? u. That's what u is. So we get e to the u, right? What does the 1 over x dx turn into? What does the answer blank say? It says it's equal to du. So there's your integral right there. So you've turned it in to a very easy integral that you can do in your head now. Okay? All right, so the antiderivative of e to the u is e to the u plus c. And what's the last thing you got to do, you think? Plug the u back in. Good. Okay, so you got to do this. That has to plug back in, and then you would have as your answer e to the ln x plus c. Okay, that's the answer to the problem. And I'll do a check on this one also as I go through this. So if we do the derivative of e to the ln x, and you know the derivative of c is 0, so you don't have to really consider that, but this is itself times the derivative of the exponent. That takes you back to where you began. Okay, so it's right. All right, so that's the idea. Okay, all right, any questions so far? Okay, so let me ask you all a question on this. Anybody have any suggestion about what I should let u be? Not 5. The whole thing, 5x minus 6. That is correct. I'll show you why. Okay, so we're going to let that be 5x minus 6. Okay, so what is du? Du is the derivative of 5x minus 6, so what is that? 5 times dx. Don't forget the dx there. Okay, now again, notice that u is going to be the denominator. We just have to make sure everything is accounted for. Okay, so there's my u, and then what I've been doing is just kind of highlighting in blue here to show you that that's what's left over. That's why that your choice of u is correct, okay? So now your integral is going to be the 5x minus 6, that's u, and then the 5 dx is going to be du. So you end up with really 1 over u du. Okay, that u is in a denominator, so it's 1 over u. And again, you're going to always end up with an integral you can do in your head. So tell me what the antiderivative of 1 over u is. What do you take a derivative of that gives you 1 over u? ln u. Okay, so the antiderivative is ln of u plus c. Okay, that's what an antiderivative ln of 1 over u is. Okay, and the last step, it's always the same. Don't forget to do this. Plug the u back in. So what you would get as your final answer is you would get ln absolute value of 5x minus 6 plus c. Okay, that's how that goes. Yes. Because that u is in the denominator, so that u has to be in the denominator, and there has to be something in the numerator. So it has to be a 1, because you could think of this problem like this if you wanted to, and this might help you to understand this a little bit better. A person could write the problem like that, right? Okay, 1 over 5x minus 6 times 5 is 5 over 5x minus 6. So that's why there's a 1. Does that make sense? That's why. Yeah, Danielle. That is asking you to find an antiderivative. Okay, so that's why when I've been checking the answer, when you check the answer, you want to see if this is a correct antiderivative. So if you do the derivative of ln, remember we learned that you do 1 over the function, then you do the derivative of what's inside. Wouldn't that take you back to the beginning? So you're doing an antiderivative when you do an indefinite integral. That's what it means, okay? Yeah, you got what you're trying to do is you can't do this antiderivative in your head. What you've learned, like last week we worked on stuff like maybe like this. You can do this antiderivative in your head. That's e to the x minus ln x. Okay, but now you can't do it in your head. So substitution is a method that changes the more complex integral into something simple. Does that make sense? That's the purpose of what we're doing there, okay? Okay, all right, let's look at the next one. Any thoughts about what you think u should be? And remember, when you take the derivative of u, that should pop up in the integral. There you go, good thought. Okay, so let's do that. Okay, so we got 1 plus t to the fourth. And again, I'll kind of highlight so you can kind of keep track of what I'm doing. So we got that accounted for. And now what's du? There you go, don't forget the dt. Okay, does that match what's left over? Yeah, you guys see what I mean? Okay, that's how you know how to set u and du. We're just going to focus kind of on this type right here then. Okay, so what we get now is the 1 plus t to the fourth. That's going to become u. You'll have square root of u. You want the square root in there. And then the 4t to the third dt is going to become du. So what you've done is you've translated this into an integral that you can do. Okay, all right, any questions so far? Okay, now how do we do this antiderivative? This is a power rule, so you add 1 to the exponent, divide by the result, plus c. Okay, so add 1 to that exponent, like that, use 2 halves, divide by the result, 1 half plus 2 halves is 3 halves, and then plus c like that. Okay, so that would end up giving us u to the 3 halves. Okay, let me ask this question again. What do you do when you divide by 3 halves? You multiply by 2/3, right? Dividing by a fraction is equivalent to multiplying by a reciprocal. So you get 2/3 u to the 3 halves plus c. That's a power rule. Okay, and then the last step is always the same on these problems. You plug in what u is because you want your final answer to have the original variable t in it. So your answer would be 2/3, 1 plus t to the fourth to the 3 halves plus c. Okay, like that. Okay, so every problem that I did kind of had the same characteristic to it. You got to figure out what u is, you got to figure out what du is, substitute, do the antiderivative, and at the end you plug the u back in. Okay, any questions? Yeah. Okay, that's a good question. Okay, what happens, what you all have to understand is when you're finished with your antiderivative, the du disappears. Here's how you can understand this, okay? Because it's an operational symbol. You already been doing this for years since you've been studying math. When you do the square root of 4, the square root's gone, right? You have completed the operation. When you do 1 plus 2, you get 3. The plus sign is gone because you've completed the operation. So if you have like the integral of 1 over u du, you get ln of u plus c, and the du is gone because you've completed the antiderivative. Does that make sense? Exactly. It's an operational symbol asking you to do an antiderivative. That's why. Okay, so I know it's weird to write that symbolism that way, but you've been doing that since you've been learning math. Okay, whenever you've always done that. That's a good question, though. That's something that pops up. Okay, so let's work on these two problems here, and I'll walk around and see if you need some help and see if we can do these okay. All right. Okay, all right, so let's see. Looked like everybody did okay on the first one. I saw a little bit of, writing the steps kind of funny, so I want to kind of get you to clean that up a little bit. So basically in this one, let's see, u is going to be x to the 6th plus 2, because you want to end up with u to the 8th, because that's an easy antiderivative to do. Du is going to be 6x to the 5th times dx. Make sure you have the dx on that. And then notice that does match what's left over. Every problem you're doing at this stage is going to work out that way. The problems are designed so they work out this way. So you end up with u to the 8th times du. Okay, you want to write down that integral. Now, when you do the antiderivative, you get u to the 9th over 9. The du disappears because you're done with the antiderivative, then you have plus c. Okay, and then the final thing that you want to do is plug in for that u, and then what you would have as your final answer could be written as parentheses x to the 6th plus 2 to the 9th over 9 plus c. Okay, so that's how you would get that antiderivative. Everybody got that too. Everybody's got that right on their paper. Okay. All right, number 2, what did you set u equal to? 4t minus 1. Okay, and the idea is you might end up with an integral with 1 over u. Okay, so we got that, and we got that taken care of. Now again, you do the derivative. So the derivative of 4t minus 1 is 4 times dt. You want to notice that that does match what's left over. So that means you did choose your u right. So you end up with, really, when you have du is always out at the side. You're never going to have du in a denominator. Just have it way off at the side, and you're left with 1 over u. Okay? Now that's kind of like, I think you were asking, Nebby, why the 1 was left over on a problem. So you understand that okay now? Okay? So basically, you have a 1 over u, and what's the antiderivative of 1 over u now? ln u plus c. Okay, good. And then you can plug this back in to get your final answer. Okay, so your final answer would be ln 4t minus 1 plus c. Okay, that's it. So I think everybody did well with that. Okay, that's kind of on Wednesday's test. That's it. That's what you have to know how to do. The second type of U sub that I'm going to go through now, I don't test on until the final exam because it's a little bit harder to learn. It takes a little bit of time and effort for students to do that. So you guys did well on that. Okay, now we get down to B. We're going to do these by U sub, but there's going to be a little twist to the problem. Slight twist. Okay. So let's go ahead on this one. We're going to let u be what's under the square root this time. So you want to write down u is equal to 1 minus 4x to the 3rd. Okay, you don't even want to look at the integral yet. You just want to go ahead and do du. Okay, tell me what you think du is. You're looking at the integral. What's the derivative of 1 minus 4x to the 3rd? Negative 12x squared times dx, right? Okay, when you do du, don't look at the integral. You're going to look at the integral now, but just get u, do the derivative like that. So here's what's different about this problem. That doesn't match, okay? So there's something different that you have to do on this problem. So the way I'm going to teach you how to do this is if they don't match, if there's no match on that du, then what you want to do is solve this equation for dx. Okay, this is just kind of a simple way to show students how to do this that'll get you going on this. So what we're going to do now is you want to take this equation, du equals negative 12x squared times dx, and then we want to get dx by itself. So what you want to do is divide both sides by negative 12x squared like that. So you end up getting dx is equal to du over negative 12x squared. Okay, if they don't match, then take that second equation, that du equation, and solve it for dx. Just always do that if they don't match. Okay. All right, so that's not a hard thing to do, but let me show you why you do this. Okay, now here's what happens on the problem. When you substitute, and sometimes the substitution part is the hardest part for students to do. The denominator, you're going to have square root of u. You're going to have that. And then what you're going to do is you're going to replace dx. Dx gets replaced with du over negative 12x squared. So replace that dx with du over negative 12x squared like that. Okay, that's not all of it. We haven't really substituted for everything. We do have square root of u, We have dx, but notice, and this is real important on this, is that you have this leftover 2x squared. So that 2x squared you have to put in there. Okay, so you need to look at that and see if you understand how the substitution went, because that's the key to getting that done. Okay, so again, du got replaced, or dx got replaced with this. That part right there is what dx is. Okay, now what happens is your integral cannot have x's in it. Right now it has x's in it, but they do cancel out, and they do work their way out of the problem. So what I'm going to do is I'm going to cancel out the x squareds, and then what I'm going to have left is I'm going to have the integral of 2 over, and then really negative 12 times square root of u times du. Now that's an integral you can do. Okay, so is there any question about the substitution? That's the part students don't understand when they first see it. Okay, leave that 2x squared in. It'll work its way out of the problem anyway. Okay, so now what you could do is you could go ahead and you could reduce this fraction. That reduces down to 1 over negative 6, and that's a constant. So constants can come out of an integral. So you could write that as negative 1/6. It doesn't matter where the negative is. You've just got 1 over negative 6. You can pull that out of the integral, and then you have 1 over the square root of u times du. Okay? So now what we do is you need to write this as negative 1/6, the integral of u to the 1/2 times du. Okay? Now, if you're going to do the antiderivative, what do you have to do with that u since it's in the denominator? You got to bring it to the top so that you can do the power rule. Okay, so what I'm going to do from here is I have negative 1/6 times the integral of u to the negative 1/2 du. So there's a lot of algebra that goes onto this problem. Ultimately, you're trying to get an integral that you can do that's pretty easy to do now. Okay, but now you're going to use the power rule. So again, when you're doing an antiderivative of u to a power, you add 1 to the exponent. So we'll add 2 over 2. You divide by the result. So negative 1/2 plus 2/2 is 1/2. Then you got plus c. And then we need to kind of simplify that, clean that up, and then replace that u back in. Okay, so I'm going to have negative 1/6. Again, when you divide by a fraction, you're really multiplying by the reciprocal. So just write that as times 2 over 1. Then we have u to the 1/2 plus c, and then we're almost done. Okay, so you can reduce this fraction. 2/6 is really a third, so you'd end up with negative 1/3 u to the 1/2 plus c, and then the last step is to plug back in your u. Okay, so that u is going to plug back in there. That's always the last step on the problem, so you get negative 1/3 times parentheses 1 minus 4x to the third to the 1/2 plus c. This is a little bit harder problem to learn how to do. That's why I don't test on this till the final, so it gives you a little bit of time to learn it. Okay? Unless you would like me to test you on Wednesday. What do you think? You don't want to? Okay, so yeah, I usually kind of have my students in mind when I test. I really do. I know it takes time to learn some of this stuff. Okay? All right, and this is an example that's got a lot of algebra in it, so it's a little tricky to see. I think the next example I'm going to do is probably a little simpler to follow. But that's the idea. So get that down or get a picture, and then we'll move to the next thing here. And I'll let you do a few problems before we take a break on that. Okay? Okay, so let's kind of work with these right here. All right, so when you do u on this one, you want u to be the denominator. So you want to write down that u is 10x minus 3. Okay? All right, now don't look at the integral. What is the derivative of 10x minus 3 anyway? 10. So du is 10 times dx. Okay, so what I'm trying to kind of get you settled on here is that 10 dx did not match what's left over. Okay, so if that happens, then you need to solve this equation for dx. Okay, so take this equation and divide both sides by 10. And what you'll end up getting is you'll get an equation that says dx is equal to du over 10. Okay? So I let u be equal to 10x minus 3. I got du. I know that's not a problem for anybody. And then solve for dx. I also know that's not a problem for anybody. So what tends to happen now is the substitution. This is where students struggle when they first learn this, okay? So what would I replace 10x minus 3 with, first of all? U, good. Okay. Now what would I replace dx with? Du over 10, good, okay. That's why we solved it. So that's du over, du over 10. The 1 is still there. Okay, so you have to see that the 10x minus 3 was u, and then dx was du over 10. Now, this is an integral you can do, okay? This is a constant, so you can bring the 1/10 out of the integral, and you'd be left with 1 over u times du. You have to have 1 over u because u's in a denominator. You have to have a numerator, okay? So see, that one is not as hard to follow as the problem I just did. There's not as much algebra going on. Okay. All right. So what's the antiderivative of 1 over u? ln u. Okay, good. Okay. So we end up getting 1/10 times ln absolute value of u plus c. And remember, when you're done with your antiderivative, the du disappears. Don't let that bother you. You're done with an antiderivative. You don't have that notation anymore. And then the last step is going to be to plug in the 10x minus 3 like that. Okay, so what we're going to have is 1/10 ln absolute value 10x minus 3 plus c like that. That's your answer. Okay, that one wasn't as bad, I think, as the first one. I probably should have done that one first. Okay, any questions? Okay, when you do some problems here in a minute, the key thing is going to be, can you get everything substituted in so that you can get the antiderivative? Okay, all right, next problem. Any thoughts about what u might be? That's right, okay, that's the best thing to let it equal to, and there's a reason why we do that. Okay, so x to the third minus 3x plus 7, that will be your u, so you want to write that down. Now, don't look at the integral. A lot of times students say du is x squared minus 1 dx. No, it isn't. Don't look at the integral. What's the derivative of x cubed minus 3x plus 7? Okay, and then times dx. Okay, all right, now let's see. Okay, so what we've got is we've got u as that denominator, and now du does not match what's left over. Okay, so if it doesn't match, what do you do? Solve for dx. Thank you. Good. That's what you do. So what you need to do is take this equation and divide both sides by 3x squared minus 3, like that. Okay, if they don't match, that's why I'm trying to highlight these in color so you can kind of see what I'm talking about by that, then do that. Okay, here's the part that students sometimes struggle with when they're learning. So what do I replace x cubed minus 3x plus 7 with? U, good. What do I replace dx with? Exactly, that's why we solved it for dx. So that will be du over 3x squared minus 3. Now, the x squared minus 1, you just have to bring that down. Don't forget to do that, because if you don't, you're pretty well messed up. Okay, what's going to happen is the x's are going to cancel out of the problem if you do your algebra correctly. Okay, so any thoughts about how I can get all those x's to cross out? What can you do with the 3x squared minus 3 algebraically? Take a 3 out. You can factor a 3 out, right? So that's what we want to do. So just bring everything down. We have integral x squared minus 1 over u times du. Go ahead and factor that out. And look at that. Now something cancels out. Okay, I have to make the problems up so they work this way. If they don't work this way, you can't do it. Integrals in higher calculus there's a lot to learn if you take higher calculus on how to do integrals. We just keep it simple in business calc. Seriously, okay? It's about as complicated as it'll ever get. Okay, so we got this, and then we have a third. So that 3 is in a denominator, so you can take that out of your integral. And what you'd be left with is 1 over u times du. Okay? If it helps you when you cross that out, you're left with 1 over u. Okay, and then you have a third that's a constant like that. Okay, so what is the antiderivative again of 1 over u? We keep seeing that. ln u, good, okay. So repetition, you start kind of seeing these things easier. Okay, what's the last step? Plug in u, good. All right, very good. Okay, so what we would have then as our answer is 1/3 ln x cubed minus 3x plus 7 plus c. That would be your antiderivative. If you took the derivative of that, it would take you back to the beginning. So it's like any of these problems, you can tell you're right. Okay, so I'm going to let you do just 2 problems and we'll take a break, and I'll come around and see if you're doing okay. You might need a little help. What's going to happen is du is not going to match, so you're going to solve for dx, okay? Let's see, what we should do on this, first of all, is we want to let everybody kind of knows what to set u equal to. What's wrong with my pen? Come on. Okay, there we go. So what we have on this is x to the 4th plus 16. And then du is going to be 4x to the 3rd times dx, like that. Okay, so we got that, like that. And then again, notice that it does not match. The 4x to the 3rd does not match. So what did I tell you to do in that case? Solve for dx. Okay, it looked like everybody did that. So you solve for a dx. So you're going to do this. Okay, and then what we're going to have on this is we're going to have du over 4x to the 3rd is equal to dx, like that. Okay, everybody did that okay. There's not a single student who didn't do that right. The problem is how everything gets substituted in now. Okay, so what do you change the x to the 4th plus 16 to? U, okay, and that's u to the 6th, right? What do you change dx to? du over 4x to the 3rd. Okay, what do you do with what's left over? See, it's a good idea to kind of cross things out. We're done with that stuff, but we got an x to the 3rd. So what do? You just write it down. That's what a lot of you didn't do. Okay, is that okay? You got to know how to substitute. Now what happens is the x to the 3rds cross out and just write down what you're left with. You really have u to the 6th over 4 du, and then you've got an integral that you can do, okay? So take the 1/4 out, so you're going to have 1/4 integral u to the 6th du, like that. Okay, and then I asked a bunch of you what the antiderivative of u to the 6th is, and a lot of you didn't know. So what is it? Okay, you're going to know that by Wednesday? You better, or you're going to be in bad shape. That is the power rule for an antiderivative. So that is 1/4 times u to the 7 over 7 plus c. So that's 1 over 28 times u to the 7 plus c. And then you plug back in. So the last step is plug u back in. So you get 1 over 28, parentheses, x to the 4th plus 16 to the 7th plus c. So that's how that problem goes. So the issue that you're having is substitution, building the integral that you can do. You kind of change it into a simple integral. Okay? All right, any problem? Yeah, you could also write the answer as x to the 4th plus 16 over 7 all over 28 plus c. Same thing. Doesn't matter. Okay, all right? Okay, very good. Okay, what did you all set u equal to on the second problem? 5t squared plus 2. Okay, so that will be kind of what the bottom is going to turn into u. So tell me what du is. 10t times dt. Does that match what's left? Okay, it doesn't, so what do? Solve for dt. Good, okay, so we need to divide both sides by 10t like that, so we end up getting dt equals du over 10t like that. Okay? All right, so that's how you would start that. Now here's the substitution. Okay, and you can just kind of mark things out as we go. So what do we replace 5t squared plus 2 with? U, good. What do we replace dt with? du over 10, good. Or du over 10t, I'm sorry. Okay, what do we do with the 20t? It's still there, so we just bring it down, okay? So that's how you should have got that substituted. Okay, what happens? Cancel, okay, t's cancel. That's really a 2, isn't it? 20 divided by 10 is 2, okay? So what we end up with is we've got the integral of 2 over u times du like that. You've turned it into an easy integral that you can do. You can take the 2 out, because that's a constant. Then you have the integral of 1 over u du. Okay, so the antiderivative is ln u plus c. Then you plug the u back in, so your final answer you should have got is 2 ln 5t squared plus 2 plus c. That's it. Okay, did anybody get that second one? I didn't check anybody's paper. You got it okay? Okay, very good. Okay. All right, questions on that? Okay, all right, let's go break here till about 5 till. So that would be what, 9:55. Let's take a 10-minute break and then we'll finish this. Okay, so what we're doing on this one is this is a differential equation, which we talked about last time. And so we're going to solve this differential equation. So what we have is this is a derivative. You've been given a derivative. You're going to find the original function m. So you want to go ahead and write down, start by just writing down the problem that I gave you. So we have the derivative dm over dn is equal to 10n n squared minus 8 to the 7th power. Okay. So a good way to approach the problem to begin with is multiply both sides by dn. Okay, so what we're trying to do is what we call this is a separable differential equation. You want all of your variables kind of on different sides of the equation. So what we'll have is dm is equal to 10n n squared minus 8 to the 7th, like that, times dn. Okay, so that's a good way to start the problem. Okay, now, if I'm going to find m, I have to do the antiderivative. See, I've given you a derivative, so you have to do the antiderivative of both sides. And again, that's what the integral does, is it tells you to get an antiderivative, okay? What do you suspect the antiderivative of dm is? M, okay? Because when you take the derivative of m, you get dm, right? Okay, we're working backwards, okay? Now, this problem right here is a U substitution integral. Okay, so what we're going to do is kind of focus on what we just learned how to do. We're going to do U substitution. Okay, so we'll kind of put this together over here at the side. Okay, what would you like me to set U equal to in this integral? N squared minus 8 is a good choice. Why are you doing that? Because it would be great if you would end up with the integral of U to the 7th, right? Okay, you know how to do the antiderivative of u to the 7th. That's u to the 8th over 8. Okay, all right. So tell me what du is. Don't look at the integral. Just tell me what du is. 2n times what? dn. Make sure the variables match like that. Okay, so based on what I was teaching you earlier before we took our break, okay, this does not match. So notice the 2n dn does not match the 10n dn. So what do you do? Solve for dn. Thank you. Good. Okay. All right. So we'll go ahead and solve this for dn. So we'll divide both sides by 2n. Okay. And that will end up giving us then dn is equal to du over 2n like that. So it's the same kind of problem we just did. We just weren't solving an equation on that. Okay, so let's see if we can kind of get this stuff put together. Okay, so what do I replace n to the 2nd minus 8 with? U. So I have u to the 7th. What do I replace dn with? There you go, du over 2n. Okay, Now see, one thing you guys can do on this is just kind of mark things out when you're done with it. So what's left over? 10n, so bring it down. Okay, that's what I think some of you are having trouble with. So that's how you get everything substituted out. What happens algebraically? N's cross out, they work their way out of the problem. If they don't, I wouldn't even give you a problem where that didn't happen. Okay, so you would end up having 10 over 2 is 5. So you end up with m is equal to the integral of 5u to the 7th times du. Okay, so that's how you end up getting that. Okay, is that okay? Okay, I sense that you understand this a little bit better. It takes a little bit of time to do that. Okay, now you can do this in your head. So 5 is a constant, so when you get your antiderivative, you have 5. Now, what's the antiderivative of u to the 7th? U to the 8 over 8. Okay, that's your power rule. Good. Okay, some of you were kind of shaky on that earlier in class. Okay, so we're making progress. Okay, so we got that, and don't forget your plus c. Okay, what's the last step? Plug back in whatever your u is. So the u was this thing right here. So that's always the last thing you want to do is plug that back in. Okay, so that plugs in like that, and then your final answer is you would have m is equal to 5 parentheses n squared minus 8 to the 8th over 8 plus c. That's how you get the answer. So that's U substitution, but it's in the context of an equation. It's in a differential equation. Okay, so that's how that goes. Does that look okay to everybody so far? Okay, all right, let's do one more, then we'll kind of get this wrapped up. And this next problem has got one extra little twist in it. Okay, all right, so this one, what you're doing is you are given a derivative of enrollment. So that E is representing the enrollment in a college. So that's going to be dE over dt equals 500t plus 1 to the negative 3 halves. What we're going to do on this is we're going to ultimately find the enrollment in 15 years. Okay, so the first thing you have to do is you have to find what E is. Okay, so what you want to do is start by writing down the derivative that I gave you. So that's dE over dt equals 5,000 t plus 1 to the negative 3 halves, like that, okay? And then we're going to have to work backwards. So what we want to do first of all is multiply both sides by dt. That's just separating the variables. That's why we do that. We want anything that has a t on one side and anything that has an e on the other side. Okay, so that's what that point of that is. So we have dE equals 5,000 t plus 1 to the negative 3 halves times dt, like that. Okay, now what we're going to do is we're going to do the antiderivative. So what you have to do is the integral of both sides of that equation to get your antiderivative. Okay, all right, what do you think the antiderivative of dE is? E, okay, it's going backwards, okay. Now the next one right here, you would have to kind of do U substitution on. So we have to do a U substitution integral on this one. So what we're going to do is this is going to be the U part right there. Okay, so U is going to be, we're going to let U be t plus 1. Okay, so tell me what du is. 1 times what? dt. Make sure it has a dt. Okay, it's got to be dt. Okay, all right. So now let's kind of look and see if this matches or not. Okay, so we ended up with 1 dt. So we got that. Now, here's something you can do in this problem. Okay, instead, one thing that you could do is you probably would want to do this. You would be wise to do this on this problem. You could take the 5,000 out of the integral, and then you would be left with 1 times t plus 1 to the negative 3 halves times dt. And then everything matches. Okay, so what I want you to see on this is u is t plus 1, so that'll be taken care of. And then 1 dt, that's already there. So we don't have to solve for dt like we were on the previous problems. Okay, so if you take the 5,000 out, that actually simplifies this problem. Okay, So what we'll have now is this is going to be E, bring down the 5,000. Okay, what are you going to replace t plus 1 with? U, okay, so it's u to the negative 3 halves. What are you going to replace 1 dt with? du, right? Okay, so we got the integral. We're now ready to finish up that integral. Okay, so that one already matched, so we didn't have to solve for dt like we did the previous problems we were doing. Okay, okay, so now we're ready to do this. So now here's this thing again. What do I need to do the antiderivative of u to the negative 3 halves? What do I do when I have u to a power? What have you been doing? Add 1 to the exponent, divide by the result, plus c. Okay, so do that. Okay, so we'll do negative 3 halves plus 1, divide by the result, which is negative 1/2 plus c. That is the power rule for an antiderivative. Okay, so what we'll have now is E is equal to 5,000. How do you want me to handle that divide by negative 1/2? Multiplied by the reciprocal, good. Okay, so that's times negative 2 over 1, u to the negative 1/2 plus c like that. Okay, so we're getting close to having our antiderivative now. So we have E is equal to, you can multiply that out to get negative 10,000. And then I'm going to go ahead and put that down in the bottom, making that u to the 1/2 plus c. And then I'm going to just bring up, kind of write the final answer to this part of the problem right here. So I have E is negative 10,000 over the square root of u, but then u you're going to plug back in. So you want to plug the t plus 1 back in, plus c like that. Now we're not done with this problem, but that is the antiderivative right there. Okay, so that's using U substitution. That's what makes this section a little bit different than the 3.03 we were working on last time. Okay, now one additional thing you got to do on the problem is you got to find C. So there's 2 steps. Step 2, what we're going to do is we have to find C. So you have to read what the problem gave you. The problem gave you that if T is 0, then the enrollment is 2,000. Okay, that's what that statement right there says. So what you're going to do then is everywhere you see a T, you're going to replace that with a 0. And where you see E, you're going to replace that with 2,000. Okay, that will allow you to have an equation that you can find C on. Okay, so what we'll get here is 2,000 is equal to negative 10,000 over square root of 1 plus C, like that. Okay, square root of 1 is 1, so you would just have 2,000 equals negative 10,000 plus C. Then you can add 10,000 to both sides. And then you end up getting what C is equal to. Okay, so we get C equals 12,000 like that. So you're given an initial condition which allows you to find C. So that gets plugged back in like that then. Okay. All right, so then the answer on this is going to be E equals negative 10,000 over square root of T plus 1 plus 12,000. Okay, that's what we're doing in the first part of the problem is we're trying to get that antiderivative and using that initial condition when time is 0, the enrollment's 2,000. That's how we get the C like that. Okay, do you guys have questions about what I did? Okay, the only difference with this problem is we're just trying to find what C is, and then when you read the problem, this is the easy part now. Hopefully this is the easy part. The question finally says, find the enrollment in 15 years. So how am I going to find the enrollment in 15 years? What do you think? Plug it in, exactly. Okay, so E of 15, you just need to replace the T with 15. So we have negative 10,000 over square root of 15 plus 1 plus 12,000 like that. Okay, and then we can do that mostly on the calculator if we need to. So this would be negative 10,000. I think I got an extra 0 there. 10,000. You would have square root of 16. Square root of 16 would be 4. Okay, so that would end up giving, let's see, negative 10,000 divided by 4. We could do this all on the calculator if you want to, or you can do it in your head, doesn't matter. So negative 10,000, and then divide that by 4. That'll give negative 2,500, and then plus the 12,000 that we got for C. This will give the enrollment. So the enrollment is 9,500 students is the final answer to that problem. Okay, so that's how that gets put together. Okay, a lot of stuff on this problems. Now, anything like this with U substitution, you won't have to worry about until the final exam. But U sub is kind of the basic ones that I taught you today. You'll see like a couple of problems on your test that have that. All right.